Hey everyone, today let's dive into the topic the different types of digital images. So, in the previous video, we have explored what is an image, what is an intensity, what is a pixel value, and what could be that intensity value representing. It could be representing temperature, pressure, or some brightness. We have also seen how an image is stored. It is stored as a matrix of m rows and n columns. Now, depending upon the type of camera that you have and the application in which those cameras will be used, there are different types of images available. For example, the satellite cameras will output some satellite images which is completely different and cannot be captured from what a normal DSLR camera or your mobile phone cameras capture. Now, irrespective of the different types of cameras and the application and where those cameras are used and the corresponding types of images that we get from those acquisition devices, we will try to explore in this video what is a binary image, a gray image, and the color image, and the other three different types of images in the next video. So here I have taken for a pictorial representation how a butterfly, of course, all the butterflies look slightly different in their features, but how it looks if you have captured a butterfly and represent it as a black and white image, gray image, or color image, how those butterflies look. So this is just a pictorial representation. Now let's understand what is a black and white image. So black and white image or a BW image is also called as a binary image because all the pixel will have only two values, which is 0 or 1, and there is a single matrix. So if you see this example, there is only two colors, two which is black represented by the pixel value 0 and white which is represented by the pixel value 1, and we need only a single matrix to store such a kind of image. That's why it is called as black and white or binary image. Black and white because you can see only black color and white color, and the pixel values are only two, binary 0 or 1. That's why it's a binary image. Now, a grayscale image is also called as an intensity image or a monochrome image. Here also you need only single matrix, but the range of pixels, for example, if it's an 8-bit image, what is an 8-bit image, what is a 16-bit image, we will see a little later. If you take a 8-bit image, the range of values are 2 to the power of 8 is 256. So you have 256 values including 0 to 255. So this image will represent colors from black represented by the pixel value 0 till white represented by the pixel value 255 with shades of gray in between which are represented by the pixel values between 0 to 255, that is from 1 to 254. Or if you take this butterfly image, you can see a black color lines, white color lines, and shades of gray, different shades of gray. Eh? It needs only a single matrix to store such an image as well. Note here the color gray spelling GREY, and here we have used grayscale of image, which is also called as the intensity image. If you just Google it, so gray, GRAY and GREY are the spellings of the same color, which is referring to the transition between white and black. Or if you take a gray image or a gray color, it's a neutral color. There is no chroma and there is no hue. What is this chroma? What is this hue? We will see little later again. Also, note that there is a brightness graduation differentiation in the grayscale image, unlike in the binary image. So, what do you mean by that? Let's take these two butterflies. See, the here it is white. The immediate next value is black, and there is white, and then black and black. But here, if you see in this, there is white and there is gradual transition from light gray to dark gray. These minute details can also be captured in this gray image when compared to black and white image. So grayscale image is also called as intensity image because it represents the pixel values or the intensities are represented within some range. Then we have the color image or the true image. Why it is also called as the true image? Because that is what we can actually see. Our eyes can see, and it has some various colors. For such a type of image, we just don't need a single matrix or a single array of size m cross n. Instead, we require at least three different matrices which are combined together. So earlier, for gray image or black and white image, we needed a single matrix or a single array of size m cross n. Here, if you take a color image, the color image that we can usually see, humans can see, is an RGB image, where RGB stands for red, green and blue. We need one additional matrix for each of the channel or the color. That is, the size of this image in terms of matrix will be m cross n cross 3. So there will be three matrices. Each matrices is for each channel or each color, red, green and blue, and the size of each matrix is a two-dimensional array of size m cross n. RGB is the most commonly used because in our eyes we have red, green, and blue filters. Apart from this, we have different colors: HSV, hue, saturation, and a value, CMYK, which are more common. And what is this CMYK? At the bottom of the newspaper, you might observe four different colors inside a circle. So the CMYK color model is used usually for printing purpose. Apart from this, we also have LAB, L channel, A channel, B channel color image, YUV color image. All these colors are obtained by mixing one or the other values. So RGB is the primary source of color, and if you mix it in appropriate proportion, all of them equally, red, green and blue, you get white. And the complementary colors are CMY, and if you mix it in an appropriate portion, all the color, so cyan, magenta and yellow, you get black. You can convert between the color models as well, apart from converting from one type to another type. But if you are trying to convert from gray to black and white, it is possible, but we cannot redo it. Similarly, if you once you convert from color to gray, or from color to gray to black and white, you cannot go back to from black and white, you cannot go back to gray, or from black and white you cannot go back to color as well. So based on the applications, we have different types of images that are available from the different acquisition models like cameras. We might be able to convert from one color, or say one image type to another image type, or from one color model to another color model, but it is not necessary that we will be able to do the reverse process as well. So this is an example of the butterfly color image, which is an RGB image. Now I have already done some exercise on MATLAB and I'll be displaying those outputs. So here I have taken four images. I have read four images which are stored in the variables A, I2, I3, I4. Right now I have highlighted this part of the code, which is reading a Lena Gray 256.tif. The name of the image file is Lena Gray 256, and it is stored in TIFF format that I'm reading in MATLAB and storing it in the variable A. When I display it and you see the properties in the workspace, it is 256 cross 256, meaning there are 256 rows and 256 columns. Unsigned integer 8, that is, each pixel is represented by an unsigned 8-bit integer. Minimum value is 26 and maximum value is 242. You can call this as a gray image or an intensity image or a grayscale image because you see there is a single matrix and the values are between 0 to 255, and it's an 8-bit image, UINT 8. Okay, you don't see any other color apart from black, white and shades of gray. So there is another image which I have stored in I2. As you can see the colors, and this is purely RGB image. At any point, if you just click, you can know what is the X and Y spatial coordinate location and what are the RGB values at that point. R value, pixel value is 47, G value is 18, and 7 value is blue. Blue is the 7 value which is at this particular point. Here, if you see the image properties, it is 256 cross 256 cross 3. So, three different matrices are required. Uh, here I have represented this I2 colon 1 represents all the 256 values of rows and all the 256 values of column of the first channel or the first color, which is R. In the RGB, it is R. If you read it in OpenCV, you get BGR format directly if you just read. But in MATLAB, if you read it, you will always store it first the red channel or the red color, then G and then B. So here it requires three matrices. Each matrices is of size 256 cross 256 rows versus columns, and each matrix is for three different colors or channels, and it's a true color image. As you can see the colors which are normal human eyes can perceive. Now here you see this as a black and white image. But is it really a black and white image? You see only black and white color. There is no shades of gray. So if you see the image properties for I3, this is image I3. It is 256 cross 256. Okay, 256 rows, 256 value. Each pixel value is unsigned integer 8. Minima value is 0 and maximum value is 255. So this is a grayscale image or an intensity image. Just because there is no gray shade, you cannot call it as a black and white image. Suppose you are capturing an image of a pant or a butterfly, which by its nature, or a cup, which by its nature itself is having only black and white. Okay, and there is no gray shade. Just because you have captured it in your normal camera phone, it need not become a black and white image. Maybe the gray shades are not available in that. Or you have captured a butterfly which has only shades of gray. In your phone you see it as a gray butterfly. It need not be a grayscale image. You have to refer to the image properties. How much is the matrix size, how many matrices are used, and what is the minima value and maxima value. And there is another image I4. This is the image, and if you see the properties of this image, it is 256 rows, 256 column, and each pixel is represented by 8-bit unsigned integer, and the minima value is 0, maxima value is 1, which is representing black and white. So it is a black and white image. Now, when displaying, we are displaying it by multiplying by I4 star 255 this image. But if you display I4 which you have read as it is, like here, you get completely 0 and 1 is transformed to only black color, whereas 0 and 1 in a binary image represents black and white. Why do we have to multiply by 255? And if you just display as it is, you get a completely black image. We will see that when we answer the question to uh, this brain teaser that I have asked. I will make a separate video and we will understand why it works like that way in MATLAB. For now, if you have understood color image, gray image, binary image, let's quickly understand whether the particular image that is given here, is it a color image, is it a gray image, or a binary image, or a combination of one of these. The image shown is of type, according to me, the answer is option D. It could be a color image, it could be a binary image, or it could also be a grayscale image. Why? Excuse me. Because a binary image will use a single matrix and it has two values only, 0 and 1, representing black and white. This also falls into that category. A grayscale image uses a single matrix and it uses it uses 0 to represent black and 1 to represent white, and in between shades of gray are from pixel value 1 to 254 for 8-bit image. Here there is no gray shade, but if you see a color image, it will have three matrices. Black is represented by 0 0 0, red is 0, black blue component is 0, green component is 0, and white is represented by RGB. All of them are 255, and in between different combinations, proportions of RGB will give different colors. There is no color or gray involved. Just because an image looks black and white, it need not be a binary or a black and white image. You need to consider how many channels are there or how many colors are there, what is the minima value, maxima value. Oh, also. We will continue with the remaining types of images in the next video. Thank you.